Hey, good afternoon and happy Cinco de Mayo, everyone. First, I wanted to start out and hope everyone and your families and coworkers are safe. My name is Sean Cusack, Midwest Sales Manager for Fixed Gas and Flame Detection. I'll be hosting today's lightning webinar on the Senscient ELDS Open Path Gas Detector. As you may recall, these lightning webinars are intended to be brief, offering a 10,000-foot view of products and/or applications. Today, I'll touch on what the ELDS is, how it works, and generally where to deploy it and how it can be used. We can actually spend many days on the ELDS. Rather than boring you guys, I'm going to go ahead and spend maybe about 10 minutes or so, and then we'll go ahead and open up for questions. So, basic question, what is it? The ELDS is an open path enhanced laser diode spectroscopy consisting of a transmitter and a receiver. It's very similar to what you may be used to out there in other open path gas detectors. It can detect flammable and or toxic gas detection. So for example, if flammable, we can do methane, ethylene, and this is an open path gas detection, or we can do a cross duct with methane only. And the cross duct, that's actually designed to be mounted on the opposite sides of a flat parallel walled ducts. And as far as our ppm version or our toxic version, we can do CO2, H2S, HCl, HF, and also NH3. The preferred method on the ELDS of measurement is actually LEL meters for flammable and also ppm meters for toxics. So typically we do ranges of 1 LEL meter or 5 LEL meter for flammables, and we can do up to 30,000 ppm meters on toxics, really depending on the gas. Path lengths can actually be anywhere between 5 and 120 meters for toxics and also for flammables. It's actually gas specific. So if you had an opportunity to look at any of our part numbers online or on a price book, you'll note that we have over 160 different part numbers available depending on the gas of interest, approvals, measurement range, and also the path lengths. How does it work? Well, it operates on the principle of absorption of infrared laser light. As I mentioned before, it's very similar to an NDIR open path or a TDL, or tunable diode laser. So gases absorb light at specific wavelengths depending on their molecular composition, And then we have a harmonic fingerprint. I have found that the harmonic fingerprint can be a little confusing, so here it is in a nutshell. I'll read it for you guys. A harmonic fingerprint is a set of harmonic components introduced by target gas absorption, in which the relative amplitudes and phases of the components are known and specific to the target gas absorption line that's being scanned by the ELDS transmitter. We'll go into that a little bit more in detail, but we need to know the differences between IR and laser, and that's IR refers to parts of the electromagnetic spectrum below the visible light region. So laser diodes refer to a semiconductor device that emits radiation. Both emit radiation. IR has a longer, more broad wavelength, where lasers are more specific and shorter. Here's an example of a harmonic fingerprint. If those of you are familiar with conventional lasers, we have single point verification. Just think of those on the bottom as it's not a harmonic, it's a fingerprint. So if you only have a single point verification, you will have a low false alarm rejection. More false alarms, that means. But if you look over to the right, and the Senscient ELDS, conversely, offers 4 points of verification where there's a high false alarm rejection. So that is one of the benefits of the ELDS, where false alarms are pretty much a no-show. How do they work? I'm sorry, I think I over-triggered it. There we go. How do conventional TDL devices work? Well, you do have a laser beam that traverses or moves from monitored path length between the transmitter and also the receiver. You will have absorption of the pre-selected wavelength by target gas that produces harmonics. Here's an example of HF harmonics. Well, amplitude of the second harmonic is produced to gas in the path. It's proportional to the gas in the path, excuse me. So how is the actual Senscient ELDS different? As mentioned in the previous slide, only the second harmonics is measured on conventional tunable diode lasers. Second, harmonics can be generated with vibration and actually poor weather, thus giving potential false alarms. Now you're looking at the ELDS on the right. It measures and compares not only the second, but the third, fourth, and fifth harmonics, leaving you with no false alarms, something that's very target gas specific and allows for greater sensitivity. Now you may be saying, I've worked with tunable diode lasers in the past. How do you differ and how do you deal with drift? Well, we all know that lasers naturally drift. They're selective wavelengths. So what we do in every ELDS device, we use a reference cell containing the target gas. And the ELDS reference cells ensure wavelength lock and are sealed for life, requiring no maintenance or refilling. We utilize appropriate material depending on the gas, so there'll be no degradation of the material and potential leaking of the gas. So as you can imagine, if you had ammonia or something reactive like HF, there would be concern, but we use appropriate material so that those gases will not affect them. So we look at a target gas selectivity. In this case, we're looking at CH4. On an OPIR is a large absorption area bandwidth of 150 nanometers. And then you can have some cross interference from other hydrocarbons and also a water vapor or water band, we call it. On the Senscient ELDS, it's only a single absorption line with a bandwidth of 0.1 nanometers, which is 1,500 times better discrimination than your standard NDIR. So you will have no cross interference from hydrocarbons or water vapor. Let's get into a little bit of application. So obviously being a line of sight or open path, it's excellent for line of sight and perimeter monitoring in large areas where point detection can be expensive to install, impractical, and even expensive to maintain. What's nice about these is it works in thick fog, heavy rain, or snow, whereas a traditional NDIR open paths typically will have some maintenance and weather concerns. Places that we've been successful, we've been in ammonia plants. As you know, ammonia point detection can be very expensive to replace the sensor cells, and you're doing it more frequently. No need to do that in the ELDS. We've done chemical plants for the HCl as a reagent or mixing agent, alkylization units or alky units in refineries for HF, ethylene production and storage, gas processing. So you could have sour gas in there. You could have, obviously you'll have methane, but you can measure for LEL meters and ppm meters. FPSOs, so in the Gulf or across the world, North Sea. Natural gas plants, offshore rigs, also refineries. So there's a plethora of other applications that I didn't mention here, but I guess the point is that we don't want to be scared of utilizing this product where we wouldn't normally use it. We can use it in bus barns, storage facilities, etc. So going quicker than I thought. So here's some resources I wanted to point out to you. We have some useful videos if you weren't aware on the MSA website, especially on the Senscient ELDS landing page, where you'll see an overview of the product. So if you look at that page, you'll see it's as a default on photos. If you just move over and click on the videos to the right, you'll see some pretty cool animated videos that talk about the sensing technology, alignment, and also overview. And then as always with all of our products, you'll be able to find some literature, which are data sheets, manuals, drawings, etc., of all of our 160 plus different part numbers that we have available. So technology yields return on investment, and I like to say a peace of mind as well. We have the harmonic fingerprint we talked about, where we have multiple harmonic detections. We have a semi-gas daily self-testing. We did not get into that, but I will talk about that briefly. That's where the transmitter submits a signal via the microprocessor, simulating absorption of the laser to match the gas of interest, and then the receiver responds accordingly by accepting or declining the signal. We have the lock cell, which is actually the physical gas inside where the laser stays stable. We also have a stay connected Bluetooth wireless technology, commissioning and troubleshooting, tablets and computers. Zero maintenance, increased uptime, and lower OpEx costs. Wider coverage for area toxics. Again, we talked about how difficult it is for those reactive gases and replacement of sensors. this is a great solution for those HF and ammonia applications. That's what I have for now. That was very fast. I do apologize, but nonetheless, I think that we can do, I'm sorry, go ahead. Angela, you there?
I'm here. I didn't say anything.
Oh, I'm sorry. I heard something in the background. Yeah, that's all I had for now. If there's anything anybody needs in the future, I'm sure that you probably can find my information online or get it from anybody else. I can certainly be happy to help you moving forward.
All right. Very good, Sean. And with that, we'll start taking some questions. We've got a couple coming through here. Please use the Q&A function to submit your questions. I see, well, and you can also use the chat too. I see quite a few coming in via chat as well. All right, first question. Can we detect ethanol vapors?
Ethanol is not an option. If you want ethanol, perhaps you probably want to go with the standard open path, NDI open path.
Okay. Here's one. You mentioned the ability of the unit to detect methane and H2S. Do you need 2 units to accomplish this? Is this methane and H2S the only options for dual gas if you can accomplish this with 1 unit? I guess I should have said that in 2.
Yes, you can do it with one. Yes, you can do it with 1 unit, and it does have 2 4-20s out. So you'll have 1 4-20 for methane, 1 4-20 for your H2S. Or if you chose to go in a direction that you can utilize 2, you can use 2. But the answer to the question is yes, you can use 1 dedicated for each, or you can use 1 for both.
Okay, and so there was another question about, do we have any dual gas option units? So we only have the 1, correct?
We only have the 1 that's for methane and methane and H2S, excuse me.
Okay.
But there are a number of these units. There might be a question moving forward, such as HF or even ammonia. They do have dual 4-20s, so they do have different ranges. So, for example, like an HF 0 to 5,000 range unit, I can actually bring that down to a 0 to 1,000 range unit by utilizing the secondary 4-20 output.
Okay. Have you had any success in ammonia in cold storage applications, or is the ELDS more cost prohibitive?
I think that it's probably going to be cost prohibitive. I don't think we want to talk about the pricing structure on them now, but I don't see why it certainly can't be an option. I personally have not had any experience with it.
Okay, here's a more technical question. Can you comment again on how the 2nd, 3rd, 4th, and 5th harmonics are a differentiator?
Basically, it's touching of 4 points. So if you were to physically look at your fingertip, at your fingerprint, a normal TDL would only look at 1 of those lines. We're looking at 4 lines. So that's basically taking care of everybody's fingerprint's not the same, nor is every gas. So it's avoiding any other interference that may come into touch with those lasers. Each gas has its own unique fingerprint, just like you and I.
Okay. Can SO2 be picked up with H2S or cause interference?
No, it cannot. No, it cannot, and no, it will not.
Okay. Can a detector differentiate between multiple hydrocarbons that may have similar 2nd, 3rd, or 4th harmonics?
No, again, this is it's a fingerprint specific. So the only hydrocarbon gases that we can currently do are methane and ethylene.
Okay.
The fingerprints are a little bit more challenging. Yeah, the fingerprint's a little more challenging than something like a propane. You'd have to use something of a wider band.
Okay, and when you talk about harmonics, do you mean frequency?
It's frequency and amplitude. There was one, see if I can go back here. There's one slide in there that actually had the frequency and amplitude of, I think it was H2S in the beginning. I kind of skipped over it because harmonics can be a little bit crazy. Here's your frequency and amplitude of HF. That's what Harmonics is. I don't want to go too deep into the weeds in Harmonics because it gets a little crazy.
Okay. Is the cross-duct minimum distance 5 meters, or does that unit go smaller?
5 meters, I believe, is the minimum for a cross-duct unit.
Is there really zero maintenance?
As far as I know, unless it gets hit by a person or a truck, you would have to realign it. There's no calibration, there's no testing, etc. I mean, you can do a senior gas test on it anytime you want. Otherwise, it's happening every 24 hours.
Okay, that kind of dovetails into the next question. Can you explain a little bit about the alignment process?
We do actually have a video, but there is a scope as part of an accessory, and it's kind of like a rifle scope. And we show exactly how to do it in the video that I was pointing at earlier on our website.
And then do the ELDS optics need to be cleaned occasionally? Does the instrument advise the site technicians if cleaning is required?
I don't recall what the obstruction is. I want to say it's somewhere between 90 to 95% obstruction, and then they'll go ahead and give you a beam block fault. So obviously that's probably the only maintenance that you'd be needing to be concerned about, is making sure that the optics and the windows are clean.
Okay, are the optics of the transmitter and receiver heated?
Yes, they can be, yes. You have the option of turning them on or off.
Okay.
There's what they call the desert mode. So if you have it installed in, somewhere where it's super, super blazing hot, you can turn off the heater, and you can set what time you want, or excuse me, what temperature you want it to turn on at.
Can you brief us on the cabling requirements?
As a matter of fact, I cannot. I'm sorry. I believe it's just 3-wire wiring. If you're using the secondary 4 to 20, then you're going to have to pull an extra set of cables.
Okay. Do detectors have crosstalk interferences? Is positioning important when using multiple systems?
Positioning is important because you want to make sure they're staggered. So if you have a line of them along a rack and they're right next to each other, you want to make sure that the transmitter and the receivers are opposites.
So I'm just trying to go through all the questions here. What is the power consumption of the internal heater in the laser source?
I'm sorry, I don't have that data memorized. I'd have to look at the data sheet.
So it's available in the manual for the most part?
That's correct, yes.
Okay.
Lots of good questions.
Yeah, I'm trying to go through them all.
I didn't take a snapshot of the manual and memorize it.
Yeah. Okay, here's
I can
one.
certainly find that information.
Okay, I'll give you the gentleman's name and then you can try and figure that out. I have an area of tight piping. What is the minimum diameter clearance space needed?
Depending on how long the unit is, I want to say it can go anywhere from inches to feet, because the laser does spread out over a course of distance. But you can have, I think, probably about a half a degree of alignment or off alignment in order for it to still have a strong signal.
Is this a Bluetooth device? Can you place the unit into a test from ground level?
It is a Bluetooth device. It can be Bluetooth or RS-485 and 4 to 20. But setting it up, only RS-485 and Bluetooth.
Okay, I've got a comment here from one of the guys, and it says the cross-duct minimum is 0.5.
Yeah, and it was 5.
Okay. Um, Now I might be skipping some of your guys' questions. If I do, I apologize. What is the maximum distance range covered for HF?
Oh, I want to say 120, but for some reason I'm thinking it's shorter than that. I'd have to go and look at the specs on that. I know there's a 40 available. I think there's a 60 available, and I want to say there's a 120.
Does the user need any software to set up the unit?
Well, yes, they do. We call it site software, SITE, and it actually is preloaded on the hardware that you would acquire from MSA, whether it be a tablet or a computer.
Do you suggest buying a tablet?
I would suggest buying a tablet from MSA as part of the required accessories, yes.
Okay, does this support HART communication?
GP, also XP. I'm sorry?
No, go ahead, Sean, go ahead what you were saying.
I was going to say we have tablets that are basically Microsoft Surface Pros, I believe, is a standard, and we also have XP tablet as well as XP computers available.
So the next question was, does this support HART communication?
Yes, it does have HART communication, but I believe you still need the site software in order to commission the unit, because you have to connect them with the site software. You have to connect the transmitter and the receiver, and then do your alignment check. And it tells you what kind of signal strength is there, and if it's ready to go, it'll be deployed.
Okay, is the laser safe to look at?
It is. I want to say the class 1, which is eye-safe laser, if I remember that classification.
Okay.
But there's no need to look at it, trust me.
I can't remember now if I've asked you this. What is the power consumption of the internal heater? Was that one?
Yeah,
that
you did
ask.
I just don't remember.
Okay. Okay. It seems the simulated gas check can replace a gas check or calibration. Does MSA find the simulated gas check useful for HF applications?
Well, that's exactly what it's for. I have seen a video where someone is filling up a gas check cell in a laboratory, of course. I don't recommend it, but that's the entire point of the Sinu gas, is to a gas check function. I don't think anybody would want to put HF in a gassing cell.
Okay,
I've seen it done, but I don't recommend it.
Okay, I've just been informed that HF is good up to 120 meters.
Hey, I got that one.
Is an air curtain available for the lens?
Not that I'm aware of.
But we do
Maybe
offer.
someone can correct me if I'm wrong.
We do offer a snow shield or something to that effect, don't we?
That's correct. All it is the bigger squall shield, kind of like a brim of a hat. It's just a longer one. So you have a standard shield, and then you have an elongated one as well.
Okay, I think I've asked a few new ones that have come in.
Any of my counterparts on the call, if your reps have any additional questions that you feel that you cannot answer, I'll be more than happy to assist.
Okay, well, I think, well, here's one. Is there a settable delay if someone is blocking the beam?
There are time delays. I just don't know what times you can set them for.
All right, I think I might let you off the hook here. I think you've gotten to most of them. If not.
That was letting me off the hook?
Okay, wait, there's one more. Do you suggest using the Modbus for better fault diagnosis?
I would say it all depends on where these are going to be mounted. If you're looking at somewhere, let's say up high, let's say it's an ammonia rack or something along those lines, and you've mounted them 50 feet away from the ground, you might have trouble Bluetooth connecting to that. And I don't recommend climbing on scaffolding or ladders or anything like that to get to the unit. So that would be probably a good case where the Modbus would be a very good idea.
Okay.
Sometimes Bluetooth can be finicky.
All right, sounds good. I think that's it, Sean. You did very good. Thank you very much. I'm sure this has probably prompted a lot more questions. So if you do have questions, reach out to your local territory sales manager or your local rep, and we'll be happy to assist further.